thrusters. And that's one of the other areas, besides solar power, that's really developed over the last 20 or so years and gotten so much better, is our ability to make these thrusters last a long time. So that you don't have to design staged things that, just to get the life that you need to do the journey. You can actually rely on those thrusters to be able to produce the kind of lifetimes you need to accomplish the missions. And that simplifies the overall design quite a bit. So then, moving forward, we get into the Space Exploration Initiative. And I thought this was an interesting one. This was from a study that had been done for NASA by Boeing. And this was kind of interesting because we've gone down this path of sort of looking at these crew and cargo vehicles. And the idea of this one was maybe we could combine it all into one. So now instead of having to have two separate designs, two separate kinds of vehicles to move people around, let's try to combine it all into one. And in some ways, it doesn't look all that different from the concept up here than the Stuhlinger vehicle, except we've gotten a little more sophisticated in terms of what the actual landing vehicle and the return vehicle looks like. And that doesn't look all that different than say, Orion today. You've got the same basic, it's really form follows function. If we have to bring something back into an atmosphere and lose all the energy and protect the crew, it ends up being something that looks a lot like an Apollo capsule. And then again, the same thing is true here. You've got the nuclear reactor out on the end. You can see the radiators again dominate sort of the design features here. And this one, there's a lot of detail here about the size of the reactor and then the type of thrusters that were selected. But a couple of other things that are significant. Here's a big rocket again, okay? And this one was a real whopper. This is a 225 metric ton heavy lift launch vehicle. Wow. So I don't know how many of you are familiar with what we're trying to do with SLS nowadays, but SLS is originally slated to be like 70 metric tons in the first variant, going to 130. This was 225. And the reason for that was when you looked at this, all this infrastructure that was going to be required to land on the surface of Mars, you look at things like this was a 50 metric ton surface hat. Okay, so that drove the size of this. This used nuclear thermal as well. There's a nuclear thermal stage for one option, and there was an aerobrake design like that. So all of the various things that we're still trading in our architectures today were there back in the 90s. The one major difference that I can see is that we're now looking at taking these kinds of elements that have to go down to the surface, breaking them up